virtual event, and then we found this place, and they've been very gracious. It's the Sonesta Suites in Park Central, and in Dallas and Richardson. So they've been very gracious, and we love this venue here. So, and this month it's a hybrid meeting, so we've got people online, we've got people in the room, and we want to thank Michael Tan and Melissa Egan for their hospitality. With that, I'm going to turn it over to Gary so he can introduce our speaker and panel today.
Thanks, Ed. Good evening from Dallas, Texas. Gary Ramsey. What I'd like to do at this point is go ahead and kick off our online event. I've got the distinguished guest here this evening, Volkmar Kunert. He's the CEO and co-founder of Accentech Technologies. Volkmar is an entrepreneur and business development professional, currently working on his PhD in economics. He has grown an organization and markets in Germany, Austria, Switzerland, US, France, and Africa, and entrepreneurial and intrapreneurial functions. Volkmar has a strong knowledge and experience in clean tech, sustainability, electronics manufacturing, robots, and IoT. He is a director at GT Ventures, where he is building an IoT and clean tech practice. Volkmar, take it away.
Yeah, hi, thank you. Very much appreciated the introduction. And today's subject is about the economics of the Internet of Things. And how do I got to that subject is I'm writing actually my thesis about it, and specifically in the energy space, where I've done IoT projects. And once I started to do my research, I found out that there is not much research going on the economics of IoT, which kind of surprised me. So I'm going to share shortly my screen here and my short presentation as an intro, and then we're going to have a panel discussion with distinguished people in the venture capital and industrial IoT space. And I will introduce those people in more detail after my short presentation. So introduction, panel discussion, and then Q&A. So most of the people know what the Internet of Things is, but to those who are not aware of it, it's basically a system of interrelated and connected objects that are able to collect and transfer data. And it has softwares and software sensors and processing technology. So basically, it has a structure. Sometimes it's displayed in 7 levels, but short device structure, sensors, and the networking, platform and data, that's the data centers, and then data management and with front-end use. And what we're talking about today is the industrial Internet of Things. I know there's also the consumer Internet of Things, which is extremely large, but I'm going to focus our discussion today on everything from smart manufacturing to smart cities, logistics, supply chain, and so on, where a lot of things are happening right now in the IoT space. And so, as I said, the problem is I see on a macro level is that we have no idea whatsoever at the moment what impact IoT has on the world. There are some estimations, but no one has aggregated what's happening on projects. So, and companies often don't know how to make a judgment on the IoT of projects, and it's very hard to know that in advance. Yeah. So I found like 3 economic theories that I think are applicable. One is production and total factor productivity, which measures the improvements in technology. The cost benefit analysis, which is on a project base, finding out the value add of IoT. This is very, doable in energy projects because electricity is measurable. And then information economics, basically finding out the allocation through optimized decision making. So what does total factor productivity do? It basically captures the effects of changes in technology, institutions, and measures those productivity shocks. That's a macro level, on a macroeconomic level. The cost benefit approach, as I said, is very much so on a project level. It looks at specific metrics, cost benefits elements, and on return on investment, internal rate of return, net present value, payback period, and others. I saw that a lot in energy projects I did, and the results of IoT are actually measurable when measuring the different inputs and outputs, and then getting increased and better net present value. We have some expert in the panels that are going to tell you much more about this. And the information economics basically is the value of information between the difference between maximal damage when IoT is not deployed and damage if IoT tracking is available. Basically, I mean, if you look at a oil pipeline, you could say, okay, what would happen if I don't have IoT sensoric deployed and I have an oil spill overnight and millions of gallons go in the ground, and I have to pay billions of dollars in environmental damage. And then you calculate against whatever the 10 or $50 million you would have invested into deploying IoT and into sensoric that would help detect this spill much earlier. So in conclusion, there are ways to evaluate the economic viability of IoT, specifically in projects. And for those who get and who will deploy IoT in their respective companies, they can ask for those measurements. And when we look at economies and macroeconomic applications for governments and infrastructure spending, we have to simply aggregate the information from projects up into the macroeconomic levels. And I think this will be very important in the future to justify the large investments. But of course, a lot is driven by, and always in industrial revolutions, by the technologists who just do things and then things happen. So in that, we come to the panel discussion framework, and which will go from the viewpoints on overall economic impact of IoT to up to M&A criteria. And let me just introduce the panelists. I want to thank you very much for coming to this panel and provide our audience with your distinguished knowledge in your areas. Number one, Naveen Beftra, who is a managing director of Beftra and Associates. He's a M&A and venture capital specialist. And David Gale, the chief commercial officer at Totem Labs, which is a satellite IoT company. Steve Goldberg, who was the operating partner of Vanrock and is a board member in several also IoT companies. John Pezzi, I hope I said that right, partner at Sky Foundry, and Andrew Romans, CEO of 7BC Venture Capital, and Vishal Shah, Vice President of Sales at Tech Mahindra. So we have a very a good panel here, and with that, I want to just start and go into the panel discussion here. And ask into the round basically a general question, and that is, what is your viewpoint on the overall economic impact of IoT?
Well, this is Steve Volkmar. Yeah, thanks for having us. I think that the classic statement about IoT is, you can't manage what you can't measure, is always appropriate. And clearly, now that there's opportunity to make measurements just about anywhere, it's kind of opened the door. As you said, it's in a pretty important area to sort of economically make estimates. I just wanted to get one thing out on the table real first. I think when one says Internet of Things, there are many of us, I'm an old-time hardware guy, who think about the actual sensors themselves that are out, in the field, whether in whatever industrial setting we're talking about. But I think it's incredibly important, as we discuss this, that we make sure that we consider all of the back end and the data and the processing, which often is forgotten when people think about, just at the sensor point of, just from the sensor point of view. So I guess what I just say is, it's really important to sort of think about, even though the term doesn't really state it, think about it as a sort of Internet of Systems rather than of things, just because of the overall complexity.
Thank you so much, Steve. And maybe Vishal, could you tell us a little bit about the economic considerations when selling and proposing IoT projects to your customers?
Yeah, absolutely. IoT is all about outcomes, right? We're selling an outcome, not a technology. So what we've done is, especially in some of the key verticals, I know we're hosting this out of Texas. We're seeing huge traction in the oil and gas sector, in Industry 4.0, in a lot of the training areas as well, where we can actually deploy these IoT devices. We can measure, as Steve mentioned, we can measure, we can take the data, we can do advanced analytics, and we can actually prevent a particular oil rig or a particular manufacturing equipment from failing. We can intervene in advance through software or through a mechanic, and actually save the company millions of dollars. So that's one big application of IoT. The second is around safety and safety sensors, right? What's the value of one worker's life saved, right? It's in the order of millions of dollars. So to me, what we're doing around gas sensing, around hazard sensing, using these IoT sensors, and being able to really, before a worker walks into a particular hazard area, having him or her wear a smart helmet or a smart glass, and having these indicators in front of him that would actually show him in a hands-free manner what the hazards are, has been a huge ROI for a lot of folks in the oil and gas industry as well. So, we're seeing, we're seeing just returns of investment in the order of like 40–50% savings, in terms of leakages, in terms of oil spillage, et cetera, as well. So just the economics of this are absolutely huge. And we haven't even hit 5G deployment yet, which is going to be a order of magnitude in terms of the power of IoT and its economics.
So how do you measure those economics?
Yeah, so I think there are different ways. There are different ways to measure it. First and foremost, we usually do a pilot with our customers. We run sort of a 3-month, 6-month, 9-month pilot where we maybe deploy this in a smaller area. We take sort of a test factory environment where we will deploy it. So we have an A and B where the operation is going on normally, and then we have the analytics, the data, and some of the outcomes that we do with the IoT deployments that we've done, and then we compare the two. So and it's been pretty remarkable how we've gotten whether it's time reduced, whether it's increased uptime for equipment, whether it is just using the data, using the analytics to make better decisions for our end customers. It has been pretty incredible. And then we deploy it factory-wide or company-wide, and then it's pretty obvious from an operational perspective what the data looked like last quarter versus this quarter and the improvements we're seeing. So the operational metrics are pretty easy at that point. But that whole pilot, that whole limited rollout is a very important aspect to making sure that we are building credibility at the CTO, CIO, CFO office to get a broader deployment.
Thank you so much.
Yeah, Volkmar, can I add to that a little bit?
Yes,
I was really glad to hear the mention of pilots by Vishal. We believe pilots are essential as well, and sometimes that runs up against how organizations want to sell. Right? They want the sales guy to go out and close the big 6 or 7 figure deal right off the bat. But I think one of the big challenges on this topic of the economics of the IoT is a mismatch between how procurement looks at investments and the realities of the IoT. We too see, tremendous financial successes from the deployment of IoT. However, they're after the fact anecdotal when you get to show them. It's virtually impossible to present any type of guaranteed, and in many cases even estimated ROI before that, right? Because we're working towards the outcomes, as Vishal said, but what gets us the outcomes? It's the data. You didn't have the data before. How can you say now what the value of that data will be, right? You can't know ahead of time. And I think this makes sense to most people, but I think it runs up against procurement mentalities that in many cases are structured around what I call the LED light bulb model, right? If I buy a light bulb and I screw it in, I know what I save. Give me that in the IoT, and you can't. And I think part of that is educating the customer on the procurement side of their business, that this is not an LED light bulb or a similar device that just by screwing it in, you save. This is a way you get information that gives you better decision-making capability to get your savings there. And then there's strong evidence of the after-the-fact savings that result from these projects.
So John, one after question is, you say it's not available, the data, but you had similar projects before. Can't you make predictions on those data with the data you have available?
Oh yeah, you can compare and say, look what we did for a similar customer, a similar type of buildings, right? But that still falls into that category of what I would call anecdotal, right? And again, I think it comes up against other investments people are looking at, which can have a more direct calculation of the results. And that's where you see this mismatch sometimes with procurement departments or the people who are involved in approving the project. So absolutely, you can bring up anecdotal case studies, examples of similar applications to show here's what was possible here. That's still not the same thing as being able to guarantee an ROI like I can with a light bulb.
Hey, John, I'd like to maybe provide some perspective from the vendor side, as you somewhat described. I'm all for pilots, but I will challenge the team and the group here to think about the scenarios that I think we all seem to be falling in. We set up a 3, 6, 9 month pilot. We think we've got the metrics defined. We think we have what's necessary to define a go, no go. And it gets slowed down or delayed, or the outcome is nebulous or gray. And 6 months turns into 12, and 12 turns into 18 and 24. I don't think anyone has the answer to that issue, but getting stuck in pilot, I think, is one of the biggest, problems and issues with IoT currently. And I think that as a community, we need to work towards defining pilots better and avoiding that trap. Kind of curious to hear what other folks have to say about that.
Yeah, so David, tell me, why do you think there's this gap between pilot and adoption of real projects? Where do you see the challenge at the customer side?
Yeah, I think that's a great question. And just a bit of context. Appreciate the prior introduction. I'm the Chief Commercial Officer at Totem Labs. We're a San Diego startup. We're in the satellite IoT connectivity. We're focused on connecting asset tracking devices globally. So indeed, our customer set are those industrial groups that are working to optimize logistics and those related systems. I think the issue around pilots is one of clear definition. I think there's a lot of best practices that I think you can read about and look good on paper, but just simply aren't followed. It's not about technology, right? And it's not about trying to come up with a successful single number that describes, what you're trying to achieve. I think ultimately you're looking for somewhat of a Goldilocks scenario in which you've got a pilot that is small enough to rapidly converge to demonstrate the value that you're looking to create, but then you can turn around and scale it up as well. I feel like in projects I've been involved with, companies are aiming either too low or too high. So that might be one example of something to think about.
Thank you very much, David. And Andrew, what is your take on this issue?
Well, we run a venture capital firm, so we benefit from seeing founders kind of come into our office today and pitch us what they think the future looks like. When I think of IoT, I think that you are marrying together devices within a system to connectivity. And so that means you can connect system, hardware, as it were, to software. So Stephen was talking about analytics. I think if you think of like how you touch even a computer or a device, you can read information from the systems, that's reading, and then that becomes data to make decisions. But in some cases you can write and make a change. So you could read, is the light bulb hot or is the server card hot? And if it is, so you're reading that information, and if it is hot, you could write a change, which could bring automation saying, switch it off. We don't want Salesforce to crash, which is a simple economic measurement of if you have downtime, what is the cost of Amazon.com as a website being down? So I think there's connectivity, there's read, there's write, make changes, and then there's if it does this, then do that, and that leads to automation. And so marrying hardware together with software over this connectivity is a huge leap forward for mankind. So, trials largely come down to what you can negotiate and the skill of the sales team and your ability to get to the right people within an organization. But you could essentially look after anything. Data center, a distributed, IBM, how many devices are in IBM and how many countries and all that. You could look at an oil rig, you look at an unsafe area. So there's almost a limitless number of use cases. And I think it often comes down to the management team of these guys come out of oil rigs. So they clearly identified all these ways to have massive, value proposition. What you have to spend to get that solution is a lot less than the cost savings, the increase in revenue, the competitiveness. If you're the only company not adopting technology right now, you're going to be Kmart, not Walmart.
Yeah, so that's brings me to my next question is, what is the criteria when you, let's say, invest in an IoT company? What besides the technology criteria, what economic criteria are you looking at?
Well, I think on a venture capital perspective, you've got a range of VCs out there that have, some are investing in pre-seed, pre-product, pre-revenue. Some are investing in late stage, pre-IPO. No one cares about anything other than that you're overpaying to get into the round. So there's a big continuum of where do you play? So the question of where does anybody play in the IoT space, I would say some are going really early, some are going later. And it depends on your investment strategy of what stage you're at. I could tell stories of IoT investments that we've made. Fortunately, we've managed to exit the IoT investment, so we came out making money. But there's an expression that Steve probably knows: hardware is hard. You need someone like Steve who knows the topic and the ins and outs.
Mm-hmm. Yeah. Speaking of late stage, Naveen, what is your perspective on the M&A side when it comes to exiting IoT startups, and how you determine the value and the economics?
Sure. Thanks, Volkmar, and thanks for the invite to the panel, to you and Gary. So I want to go back just a bit to the previous discussion around pilots. And, before we talk about M&A is all around credibility. And, I get clients who come to me and say, look, we're looking for an exit. But when you dig deeper into the discussion, you'll find that, hey, either this pilot they passed on, and the discussion revolves around, we didn't have enough capital, we didn't have the. I think it's very important for the entrepreneurs in the room to understand that, as David said, you can box in that pilot, but you've got to be able to demonstrate that your platform is able to achieve that ROI that Vishal, was referring to. In terms of M&A in the IoT space, I will tell you one thing that, I get a lot of questions around COVID and how has COVID affected the M&A space. And since, I advise a number of companies in the IoT space, one of the things that I think that COVID has done, despite very traumatic consequences, is that for entrepreneurs, COVID has separated the wheat from the chaff in IoT companies. And I could tell you that 18 months ago, 2 years ago, my biggest concern with M&A in IoT or exiting IoT companies is there was very little ability to discern from a successful IoT company versus a very successful IoT company. There was a lot of fluff. And what COVID has done is really forced that separation of the winners and losers. And there's a lot more visibility to someone, say, like Vishal, who says, yes, this is something that I know can fill this hole for me in my roadmap, okay? Versus 10 companies in my lobby saying they can all do the same thing, and how am I going to evaluate this? So I think that COVID, especially in IoT, has given us this ability to separate the winners from losers.
Thank you, Naveen. And maybe Steve, I want to ask you again, first of all, from the VC perspective, but since you are also a PhD engineer, from the device perspective, where you see us going in the next couple of years?
Yeah, well, one thing, just Andrew was kind of touching on it. From the VC point of view, hardware is hard. And generally speaking, when you're an investor, any investor who can invest in anything, consumer software, enterprise software, hardware, IoT, whatever, you're looking for those markets that bring you liquidity the most quickly, right? And you're also looking for products that even with low volumes, maybe you don't do as well as you had hoped, you still get good margin. I think the movement in the world has been, at least in relatively large volume devices, is you either give them away or you run them at almost no margin, and you make the money on the service and or the analytics and or the recurring, as everyone's heard, software as a service type revenue. So I think, when a VC looks at IoT investments in general, I won't say always, never say always, but in general, you're looking for those companies that kind of create that back end value, where very sticky. Once the infrastructure's in, once those sensors are in, whether they're cameras or pressure sensors or vibration, whatever they are, once they're in, now it's very difficult to bring another vendor in, and you're just basically, getting that data and doing the processing. And the second question, I'll keep the answer real short. As far as technology goes, it's and still in the venture capital community, there's always buzzwords that come along every decade or every few years. And I think most of the audience probably has heard either artificial intelligence or machine learning. And in this particular case, you might even hear the term edge computing, which basically implies, even though communications is free these days, we all know that cellular is very inexpensive, Wi-Fi is very inexpensive. Latency has become a really big deal. Keeping a car in the lane of a highway, having sensors on machinery where you need milliseconds of response time where something really bad could happen. So latency has become a real big deal. So I think where technology is now is putting processors at the sensor before the communications to do kind of, we'll call it intermediate level processing or decision making, so that every decision doesn't have to go back to the server. And I think we're living that in real time. So in terms of technology, that's where we are. And it's going to be a few years before those edge devices get smarter and smarter, where you could actually say they make the entire decision. I don't think we're quite there yet. Companies that are doing integrated circuits for AI are just now starting to produce volumes. And I guess we'll have to do a few pilots to find out whether they work or not.
Well, and Steve, there's some other issues too. Like if you've got a sensor on a car that is directly connected to a power supply, right? So in that case, you don't have to worry about power. The connectivity could be coming over like a cell phone network, which is going to drain the battery. If you've got a little like $6 sensor on every parking space in Manhattan or Palo Alto, and you're trying to release congestion and reduce traffic by 40% in LA or something like that, those things need some kind of connectivity that's going to let that disposable sensor, parking sensor, go for like 7 years, and so there's innovative models. We funded a company that was actually called IoTerra, so IoT, kind of trying to surf the buzzword wave there, but they were selling a solution for pet owners to track their cat or dog or crazy boyfriend or their stuff, where they put this little device on the pet, and then they put at home their own little base station, which makes a cloud around the house. So it's like a base station and a cloud. And then from my house, it could go all the way to around Stanford. It was like a huge on a hill. My one house was powering like as much as a Vodafone, tower. And then they would sell a bunch of these devices for pet tracking or tracking whatever. And then all of California gets covered while selling a product that then has the kind of connectivity that does not drain these little IoT devices that have no power supply. So we've seen some very creative, ways of addressing, problems that need to be solved.
Yeah, so that brings me, when we speak about connectivity, again to David, who is representing the satellite network company. David, where do you see this issue? Because I saw, as Steve and Andrew just said, I saw a lot of business models that do the software as a service on the hardware, but then also make money on the connectivity. As we know, the Verizons, the AT&Ts of this world, they want to, of course, largely profit. And then maybe after that, Vishal could tell us something about that, since he worked previously down in San Diego with Qualcomm. Thanks.
Right, sure. Yeah, I want to maybe I'll start by answering that question, just backing up slightly, talking about Edge. I love the technology. I'm a big supporter of what it can bring to the table, and it's the right time to talk about Edge, given various ingredients. But I want to remind everybody sort of this history. I've had this model now almost for a couple of decades, that the notion of centralized compute versus distributed compute is not new. It's about a 10-year cycle, and it starts in the 50s and 60s with mainframes. And then you go to PCs, right? And then you get to networking and central drives, ultimately the cloud. And here we are again now talking about distributed processing, with edge computing. So fundamentally, we're talking about a similar set of trade-offs around the efficiency of centralized compute storage versus distributed. By all means, the landscape changes over time. So what we're talking about here in 2021, of course, is different than 10 and 20 years ago. But it's a great topic because, the answer is never one is better. The answer around edge compute is it depends. And so I love the other panelists and their examples of uses of edge compute to drive cost, the economics, things like battery life, right? To be that much better than it was. In my world, in the satellite connectivity world, we're all the way on one end of the spectrum. We are working in applications that are very low power. They're very low data. The data models are, we're talking about connecting internet trackers that maybe are pushing 5, 10, maybe 50 kilobytes a month. That's it. That's plenty of information to create massive value for these companies to learn where their pallets are, where their containers are, where rental equipment is, and what's going on at a time frame that's meaningful to them. But in that scenario, it is all about battery life, and the best way to maximize that battery life is to take that information, put it into as small a form as possible, and get it off that device into the cloud. Let the cloud do all the smart work. And that's, so to us, in the satellite connectivity world for asset tracking, we're not looking really at the edge. There may be certain processing steps we take, again, kind of compressing and scrubbing data, but there's not a whole lot that happens. And we're finding that it's best to get that information back to the cloud. So
thank you so much, David. That's great. And Vishal, since you worked at Qualcomm, can you maybe shed a light, and you're also an engineer, on the 5G deployments and on connectivity and business models there?
Yeah, absolutely. So, this whole move to the edge has been happening for a while, right? So David brings up a good point. The edge has always been there. How we use it is now changing, right? And a lot of that is coming with compute power, with AI at the edge. But those are like huge computational elements that need to be done right there at the source of the data, right? So that's a different use case, where if you have the right kind of power, the right kind of CPU, if you're connected to like a millimeter wave kind of 5G platform, that makes a lot of sense. But at the same time, talking about the kind of edge that David is talking about, which is like very low compute, very low power, we're seeing a lot of such applications in farming, for example, where you need like a sensor that measures temperature or humidity, or like a fire hazard for a particular farm in the middle of nowhere, or an oil field in the middle of nowhere. I mean, those are just fine to be on a very, very low power, low range, what we call LoRaWAN network, or something that now David can connect via satellite, right? So I think the edge is also on a, hate to call it, but the edge has a spectrum as well, all the way from like very high compute AI, with smart vision, smart cameras that are processing the data and like not going to the cloud at all. And at the same time, the edge, which is like really power sensitive and compute sensitive and actually requires the cloud. And actually, this is what's been causing a huge scare for people like Microsoft and Amazon, who always thought that data always gobs and gobs of data always has to go to the cloud, right? That's the whole model. They want you to like put that there. And now with 5G and edge, the operators and Verizon and AT&T and the Vodafones of the world are saying, hey, no, I want to do all the computing right there on my tower or on my device and not put it on the cloud, right? So now you see these big hyperscalers getting into the edge space as well. If you look at the whole Azure, Microsoft Azure IoT suite or the Amazon IoT suite, they are now incorporating edge devices as well as edge computational and AI analytics as well.
Thank you. And John, maybe I would like to take your take on what you think about the subject of connectivity and business models and how it affects your company. You're muted. You have to unmute yourself.
Thank you. In our world, where we're focused around energy and the built environment and the assets that are in them, we're not fully dependent on cellular networks. There's a lot of hardwire networks, although we do have customers, who are deploying on cellular networks. And I haven't checked recently, but someone made a comment that the data transmission costs are almost zero. That hadn't been our experience on cellular networks, and it's actually driven customers to employing the edge where they can, so that they don't have to stream every single sensor value from every single sensor up to the cloud before they can make a smart decision on it, and potentially take action, like we mentioned earlier, to actually write something down to that edge device or piece of equipment. So our systems are used with a wide range of cellular, hardwired. Once you go into the buildings or the facilities, then there's the whole question about what are the effective sensor networks there, whether it's LoRa or Zigbee or other wireless networks. And I think this gets to a different point than maybe you're asking. It gets to the complexity of these deployments, right? Now you need to know Zigbee or LoRa and all of these things. And it gets to the point that the IoT is a great term to describe how we're applying a range of technologies to get to outcomes, to make solutions, but it's not a thing. And I think that is often part of the conversation with owners. The IoT is not a thing, right? It's something we can accomplish with a wide range of technologies that, as a previous speaker said, it depends. What's going to be the best fit for low data rate, low power versus low latency, high algorithm production or processing down at the edge. And it makes for such a wide variation of skill sets and how owners and customers need to be approached. You really need to understand what are the outcomes that will make sense to them, and what's this technology stack going to look like for them. So there's just so many different examples, and I think what you can do is you can find an example where every single story is true, every single story is right, but that doesn't mean that they're applicable in other applications.
Thank you. So now one of my last questions to the whole round, and then we go into Q&A, is where do you see the technology economics going in the next 5 years? And I'm talking on a macro level, what government's doing in terms of infrastructure, smart cities, initiatives, and then on a micro level, I call that micro level now, on the business level, what are the main drivers going to be? Is it technology? Is it business models? Is it data? Thanks.
I'd make just one comment. I think this is more of an aspirational thing, but the last 10 years, we've seen this explosion in IoT, both on the hardware and the software side. The reality is a lot of proprietary networks out there, meaning a lot of proprietary protocols, proprietary hardware, proprietary data formats. It would really be nice. And I think all technology gets to this point, just like computers and servers, for example. Now you can buy just kind of an off-the-shelf server and put anybody's software on it because they're kind of standardized. It would be nice in a shorter period rather than a longer period that we saw more standardization of some of these areas, especially in the IoT space, because otherwise it becomes a, one and done, or you end up with companies that have 10 different IoT networks to serve them. It's kind of what happened in the computer networking world before people started consolidating functions. And so I think that'll ultimately happen, but that's important.
Thank you very much. And Naveen?
Yeah, I'm going to answer your question, Volkmar, a very different way than this panel. And that is, my response is, in terms of the next 5 years in IoT and M&A, nothing is going to change. And while that may be surprising, the reason I say that is M&A occurs at the intersection of greed and fear. And the companies or the entrepreneurs or the board members or the investors, like we have they have to continue asking themselves whether I am inducing fear into the IoT ecosystem, or am I just lagging behind everyone else? And that answer will tell you what type of greed you're entitled to. I watch too much TV, my wife says. So, but greed is good, right? They say in the movie. So greed is good. You've got to induce a corresponding amount of fear, whether it's today or in the next 5 years of IoT. And I'm open to discussing in more detail during the question period.
Okay. And Andrew?
I think it's inevitable to begin to digitize and add intelligence to every industry, whether it's private industry, healthcare, education, government, all these things. When you just look outside, there should be sensors on every traffic light. There should be sensors for surveillance, for safety. There should be sensors on parking. If you look at a factory, the idea of a semiconductor that's worth $20,000 when it comes off the line, if it gets damaged along the way and you can start to read, write, automate, connect to software, all these components in a system, I think it's inevitable for people to have a better functioning widget in a widget industry, whatever it is. So whatever business you're in, if it helps to digitize it and connect these things to software, it's going to happen.
And Vishal?
That's a great point. And I think in terms of IoT, I think it's a juggernaut. It's going to happen. It's been happening for the last 5 years, but I think the acceleration and momentum has just become exponential. And anybody involved in any kind of a digital transformation project at a Fortune 500 company is heavily engaged in some sort of IoT transformation kind of project, right? But having said that, I think there are 2 or 3 considerations, right, for it to be successful. It's not all, it's not a bed of roses. I think the first one is regulatory. We've all talked about how smart cities, it's so easy to go install a bunch of cameras, a bunch of sensors at every intersection, but we're seeing city after city reject that proposition, right? So I think there's this whole regulatory mindset that needs to change in the smart city space. What I like better is the smart sort of smart spaces, like smart industry, whether it's like a port, whether it's a college campus, which now can have their own private networks and have a whole bunch of sensors, IoT sensors, different kinds of smart devices like smart boards, smart monitors for education. That's coming out, right? So I think out there is the technology integration, which is a big challenge. How do you bring these different pieces of the ecosystem together? And the third challenge, I think, is going to become security, right? Now you got millions and billions of sensors around the world, and we've seen, the Nest being hacked. We've seen the Ring monitor being hacked on the commercial side. On the consumer side, you can just imagine what happens when you have a 5G denial of service attack on, an entire plant at GE or ExxonMobil. So, that the third thread is security, and that's sort of something that needs to really be gotten right along with the whole integration process.
No,
And
Vishal, I just wanted
David?
to add something
Oh,
that
sorry.
you made me think of, that there's a little bit of a problem on a nationalistic level that, Steve knows that VCs, if they have a choice, if I can invest in anything, I'm going to invest in some digital river like Skype, where if there's a problem, I can send out a quick service book, fix it, no problem, as opposed to hardware is hard. A mistake can be very punishing. And even with 3D metal printing, it's like not the same as digital. Whereas China, they're, right at their centrally planned, like USSR, CCP decision making, Beijing says, okay, Xiaomi, you do this, Huawei, you do this, you do this. And it's all about, they're the factory of the world.
Yep.
So they think hardware, they smile when they see hardware, they see money,
Yep.
they see dollar signs in yen. So right now we're kind of facing, the Japanese are just not making any decisions. They're like giving up to the Chinese. The Americans are all chasing that quick, easy liquidity Stephen is talking about. But I think it would be nice to see some initiatives, and you just cannot rely on the US government to lead us anywhere on this. But I think there's something interesting that the Chinese are so into hardware.
Yeah.
They're forcing people to put money in. They're putting guns to the head of their state-owned enterprises. They're private companies like Huawei, that's not an SOE, where one of the 3 CEOs is a former general in the Red Army. They're totally going to dominate, hardware. And it's something to think about. Are we going to totally give it up to the Chinese to dominate the space that, Volkmar has shown how important it is?
Yeah, thank you. That's a very strategic thought. David.
We need a geopolitical expert next time on the panel too.
Right.
I think, David, that brings us right to David, because maybe the satellites can solve mitigate some of that dependence, not on the hardware level, but certainly on a strategic level.
Well, it's possible. I just a couple of quick comments. One is I do want to tee off the geopolitical. I think it's important to always keep your eyes, globally. And I'm not talking about satellites. I'm talking more politics here. I appreciate the previous comments on China. I view it through a different lens, and that's this East-West divide that we've got going. Even post-Trump, we've got the Huawei experience, and looking towards both investment and opportunity, commercial opportunity. How does that affect us in anything from standards to regulatory to protective tariffs? So that can be a forcing function. Another example of that is the EU's investment in building silicon capability on continent, right? That's a specific response, to that East-West. The other is what is a post-COVID environment look like in terms of investment and need and desire commercially and politically. So there's now $100 billion on the table with a Biden plan around broadband infrastructure investment, right? How does that change the landscape around IoT, in some meaningful way? So I think there are forcing functions that are coming down the pike that need to be watched. If and how satellite and our work at Totem, can shift this, the one thing that we gain by being, 500 kilometers up in space is we don't see those boundaries, right? So we get global coverage kind of on day one of our network, and that in a sense we get to ride across some of these potential divisions, but we're influenced by these factors, of course. Anyway, we're a connectivity solution, and our customers have all of these concerns as well. So I don't think we're a silver bullet to geopolitical problems, but sometimes it is good to fly at 500 kilometers. So
yeah, and if I may add to that, it's a very good point, David. We talk about this East and West divide, but even on the IoT spectrum, there is hardware and solutions that are really, really cheap, right? That you can like operate on a Bluetooth chipset or a Zigbee chipset, or even like a 5th generation 4G LTE chipset, right? Which is like $2, $3 solutions, and not even that, right? So I'm okay with anybody outside of the US taking that business. But when you talk about Internet of Things in smart cities, there's a lot of products which are on really the cutting edge side of things, like smart glasses, like AR, VR glasses. You've got robotics that are required to like go and robotics for industrial operations or medical operations. We've got like smart drones, which we are using with PG&E right now to like analyze whether there's like shrub and foliage coming into the overhanging wires to prevent like the next $5 billion fire, right? So when we talk about IoT, is how can we even attack some of the upstream problems, which are like $500 to $50,000 devices, which will connect to the smart grid and really be profitable for some of these venture capital firms as well as some of these startups. I think that's also a way to look at IoT on the upper end as well, which can be very, very profitable and where we can even operate on the hardware. Smart connected cars is the same way. Some of these modules we're looking at that are being incorporated for smart autonomous vehicles and ADAS. I mean, a perfect example is like ADAS and automated radar systems. We had this first $50 billion company, the youngest billionaire out of Europe, who actually launched that solution, right? Which is now being used in Google smart cars and everywhere. So I think we always look at IoT as like this one cheap sensor in a factory somewhere, but I think there's a lot more that can be done both on the higher end side as well as the overall software integration and the end-to-end integration. I think that's where there's a lot of revenue potential.
Thank you. And John, where do you see the 5-year outlook?
We see sensors getting less expensive, processors getting less expensive. What we see is the cost that's going up is the systems integration. We've talked about the complexity. We've talked about the different protocols. That is not being reduced from the experiences that we're having. If anything, it is becoming more costly. It's also being limited by the access to workforce, people with the right skill sets. So, you can get to the point where, okay, if the sensors were all free, we still don't have a free project. We still have a very expensive project because the systems integration to connect these different technologies and virtually anything other than a silo product from one manufacturer is going to require integration. That cost is not going down.
Well, thank you so much for your viewpoints on those questions. So now I would like to open it up to Q&A, and I would ask the person who have something to say to text that in the chat box, and then I would read it out to the panelists. And we're probably then going a little bit over if we have a lot of questions, but this is kind of the end of the official panel discussion. I don't know if you're able to use the chat.
The chat is disabled.
Okay. Okay, then everyone. Okay, it's enabled now.
Gary, can you enter questions? Does anybody have any questions here? I think Gary did.
Yeah, and also we could ask the audience in Texas.
If you could please repeat the questions that are being asked in Texas there, closer to the mic so that we can hear them, that'd be wonderful.
If we're on, I do have a question here.
Yeah, thank you. Could you guys speak to the proposed capital gains tax increase and the impact you think that's going to have on capital formation to fund all of this innovation for edge computing and deployment? Thank you.
Did you guys get that question?
Yeah,
Yes.
Volkmar, did you get it?
Yes, I understood that the question was in how far the changes in capital gains tax will influence the investment climate in IoT?
I had just a quick response. It's a great question because it's obviously a very current topic. I think it's just like everything else. The pendulum will swing wide. Right now, it's swinging towards, several $1 trillion worth of government spending. How are we going to pay for it? And then, obviously in other decades, it swung the other way where the government, doesn't spend a lot, and the idea is to build surplus. I think, we could see little blips over a few years where people get anxious and investment drops and this kind of stuff. But I think it's cyclical. So from a venture capital perspective, we usually look at, 10-year plus horizons. I just don't think it's going to have a major impact. It's not in the government's best interest. And I think there's plenty of people on both sides to sort of keep it in the middle.
Thank you.
Got another question?
We just got a question here from Bert from Infinrel. He asks that PitchBook has shown an average of 27 times revenue multiple for AI IoT companies in 2020. What is the value when it seems from the discussion many projects are stuck in pilots?
I'll jump at that one. I think we had an IoT company that was selling these pet trackers where every home became a base station, building out that network. And if our revenue had been, just for simple math, $1 million, and they were valuing us as 27 million, when Ring acquired our company, every doorbell now became a base station. So it's a bit like, once you get one fab to buy your semiconductor thing, the guys that are selling into all the fabs can get 27x your revenue kind of overnight. So if, Yahoo bought Flickr, Google bought Picasso for photo sharing, Google can afford to overpay more than Yahoo in that M&A situation. But I think the market right now is that people are willing to pay a lot of money to get into a company that's got good revenue in an exciting area where ultimately buyers could buy that and have a multi-billion-dollar reoccurring revenue stream. And these publicly traded companies will be rewarded for making that acquisition.
Right. Let me just add to that. That's a good point, Andrew. So, I always look at multiples as a guideline, and what multiple doesn't cover, to the individual that asked the question, is really around what are those synergies. That's what they're paying for. The actual multiple is extracted from a baseline plus the synergies that exist between the two companies. So in some of the cases that Andrew just mentioned, a lot of that synergy is their thesis is we want to own the home and we own this piece of it. And so that value to us of that other piece is very valuable. If you were starting from scratch, it may not be that type of multiple because you won't have those synergies. Every deal is different. When I look at these, and I get this question all the time, right, from CEOs or board members, hey, what's this going to go for? So three things I tell them: I don't know who's going to buy it, I don't know how much it's going to go for, and I don't know how long it's going to take. But if you have value in this asset, if you, again, inducing fear of Google getting it versus Facebook not getting it, you're entitled to those kind of exit values. And if you're not, I don't care what the multiples say.
Yeah, and just to add to that, if I may, Volkmar, is we talk about industrial IoT. I know that's been a focus, and that's where we've seen the requirement sometimes to prove the pilot, and it works, it doesn't work, that kind of a dynamic. But a big part of IoT is consumer IoT, right? Your Google Home, your Alexa, your smart doorbell, your smart bulbs and smart lights. I mean, those are all kinds of things that have, as Andrew mentioned, like billions of dollars of valuation, and rightly so, based on the growth curve they're in. So there's this whole consumer IoT side of things as well. And even on the industrial IoT side, when it comes to like pure sensors and pure telemetry data and telemetrics, that has been around for almost 20 years when it, with M2M, and those are now just being replaced with better modems in the 4G space and the Bluetooth space, right? So I think that the volume of business is quite incredible. In fact, Qualcomm just had its first $1 billion IoT quarter, like $1 billion sales in one quarter, right? So, and NVIDIA is doing the same, Xiaomi is doing the same. So these are, even just on the industrial IoT side, these are becoming $1 billion quarters for a lot of companies.
Thank you, Vishal. And I think we have a question from the audience in Texas.
Yes, we do. You want to go ahead and introduce yourself and your question?
Hey, this is Sami Fadil. I am the founder and CEO of Tallbyte. So my question is, it's more like a statement open for comment here. So you guys mentioned that edge computing, like IoT, is one of the most mature edge computing use cases today. And you guys mentioned like not sending a lot of data or sending a little bit of data, and edge computing not being really a big deal, especially for satellite. I don't think that's the whole point of edge computing. The amount of data you send or latency is just one side of it. You have to consider privacy, like GDPR and so on. You have to consider security and other aspect that edge computing brings into the table. Is not just about how many data you send. So a sensor could generate a little bit of data and send that to a satellite, but that satellite might just redirect that to a nearby data center with a disk. Doesn't have to go to a cloud. And I think the cloud reference is more like, it comes from that, like people being used to a centralized model. And believe me, decentralized and distributed technology has gone way mature than the previous cycle, and they're going to take over the centralized model, and especially with Web 3.0.
So what is your actual question then?
It was just a comment open for.
Oh, okay, good.
Yeah,
Thank you.
Yeah,
I think it's
Thanks.
Volkmar. I'd love to respond to that.
Yeah.
If that's okay. I think that was a really important observation. I appreciate the comment. And I couldn't agree more. I think that in our discussion, I think we simplified edge computing to mean, local pre-processing of data to minimize, use of communication resources. So I couldn't agree more with the gentleman. Edge computing has value well beyond that. A couple of dimensions here. For one, you brought up privacy and security. I think that's a great application to keep things local or even regional. And then someone else on the panel had mentioned latency, right? Which is, it's about responsiveness. If a self-driving car needs to make a decision, keeping that data local has great value for latency. There's other attributes, but those are two great examples that don't relate to the use of communication bandwidth. Just a quick final comment there is, I also like the description that edge computing it's not always defined or needs to be defined as processing at that edge node, right? It can be a server or a compute system within a facility. It could be on a tower. It could be regionally. So the notion of edge has many definitions and shades of gray. So I appreciate the comment. So thanks for the clarification.
Thank you so much, David. And we have a question online. What would you recommend telling global manufacturers who want to manage all their sensor KPIs from multiple sites for securing their data, and how do you size the cost? I understand that is, that question is around safety, security of sensor data.
Yes, Louis here. Thank you for this panel discussion. I got a lot of incredible insights from what you guys have been talking about. It also comforts me that I'm going into the right direction. So my observation, I'm currently here in Taiwan, and I lead the development of a global IoT management platform. So one of the questions we have from some of the customers who have factories in multiple areas of the world is they want to consolidate all of those, the performance of each site and all the alarms on each site in a centralized platform. But they're sometimes concerned about the security because our platform allows you to switch some of the devices on and off. So in the event of a cyber attack, the disruption damage could be substantial for their operations. So they're asking us, okay, how would you secure the infrastructure and what would be the size of the cost relative to the project budget? Hello.
Thank you for your question. Yeah.
Yeah, I mean, I can take a question. I can take that question. I think, like I mentioned, right, one of the biggest challenges and opportunities about this whole IoT integration and mass deployment is around security. So you're absolutely bringing a very good point. So I think the heartening thing is that a lot of the end-to-end security, end-to-end providers like AWS and Microsoft Azure, their IoT systems now have Defender systems in them as well, which will add to their security, right? There are companies like Cradlepoint, which kind of really focus on securing your IoT network. There are techniques like two-factor authentication on sensors. 40% of they did a particular research, and 40% of sensors or devices still had their username and password as user1234, password 123456. And when it comes to a hacker, that's the first, they'll hack you in like 15 minutes, right? So things like 2FA, two-factor authentication that we now use on smartphones is what is being forced in some of these devices as well. And then there's a lot of things that people are doing around private clouds and private networks, right? Like if you have sensitive data, how do you make sure that you're now within like a private cloud that only you have access to, as opposed to a public cloud and a public network? So this is a longer discussion, but there are companies that like specialize in this level of details, security for IoT devices, as well as cloud and edge devices that can really help you out here.
Thank you so much. And
change the username and password.
Yeah. And I think we're coming to the end now. And I want to really thank all the panelists so much for their precious time here. If there are any more questions coming, you're welcome to send them to me. I will follow up with you, and I'm sure the panelists would be happy to connect. And so I give it now back to Texas to close the session. And again, thank you so much for your great input. I think we have all learned a lot today. I certainly did, and I'm extremely humbled and happy for coming and thanking the panelists.
Yeah, thank you both, Marn. We really appreciate your time also. And if we can maybe get a little bit of audience applause here so they can hear out in the pretty good here in the Dallas area. So again, we want to thank the distinguished panel for their time, and I want to thank all the people that showed up here at the Dallas Hotel. We're looking forward to our next happy hour, which